Okay, let's talk about the basic differences between ionic and covalent bonds, two different ways in which atoms can connect to one another. Well, let's first look at the basic parts to an atom. Here's a square from the periodic table. Be is the element beryllium, and elements are made from atoms. And atoms have three basic parts. First of all, there are the protons. These are the parts that have a positive charge. From the periodic table square, I know that from looking at the atomic number, beryllium has 1, 2, 3, 4 protons. Another part of an atom is what are called electrons. These are parts that have a negative charge. Usually the amount of protons is the same as the amount of electrons. So I now know that beryllium has 1, 2, 3, 4 electrons. And then the third part to an atom are called the neutrons. Now be careful, the number 9 in the square, that's not the number of neutrons. The 9 is when you add up the combined amount of protons and neutrons. And in beryllium's example, that'll be 9. So for beryllium, there's the protons plus beryllium's neutrons will equal 9. So we just got done saying there's 4 protons plus how many neutrons will give us 9. Simple math, there's going to be a total of 5 neutrons. So how are these parts arranged? Well, atoms have a nucleus, and in the nucleus are the protons and the neutrons. Surrounding the nucleus are these levels of electrons. Now, the levels of electrons, you might know, can only hold a certain amount. The first level, the inside level, can carry 2 electrons. 2 makes it full or stable. The second level can carry 8 electrons. 8 electrons will make the second level full or stable. And even though beryllium doesn't have a third level, many atoms do. And if an atom has a third level, 8 electrons will make it full or stable. So let me put 2 electrons in the first level of beryllium, and the electrons kind of orbit the nucleus. And so now the first level is filled. It's what we call stable. Well, the other 2 electrons have to go in the second level. And here's the problem with beryllium. It's unstable. It's unstable because the second level is not filled. The second level can carry 8 electrons, but there's only 2. That makes it unstable. So why do atoms bond with one another? Well, they bond with one another to become stable. And what that means is that they are trying to obtain more electrons so they can fill their levels. Now, there are 2 basic types of bonds, and that's why you're watching this video, is to learn the difference between the covalent bonds and the ionic bonds. Let's go over covalent bonds first. Okay, so the basic definition of a covalent bond, it's a bond between atoms where they share electrons. And so the goal of atoms forming covalent bonds is to become stable, to fill their levels of electrons. And the classic example of this is oxygen, the oxygen that we breathe, O2, the oxygen that plants make by doing photosynthesis is actually 2 atoms of oxygen stuck together. So let's look at oxygen. From the periodic table, it's got 8 protons, it's got 8 neutrons. So let me draw oxygen number 1. I'll get to oxygen's electrons in a moment. So in the nucleus of oxygen number 1 are going to be 8 protons and 8 neutrons. Well, I'm also going to draw the electron levels around the nucleus, and now I can tell you that oxygen has 8 total electrons. So when I draw the electrons, I'll put 2 electrons in level number 1 because that's all level number 1 can carry. And then I'll put the leftover 6 electrons in level number 2. And notice how the first level, the inside level, is stable because it can only hold 2, and it has 2. But the second level is unstable. It can carry 8 electrons, but it only has 6. That's a problem. It's unstable. Well, the oxygen that we breathe is actually made from 2 atoms, so we have to draw a second oxygen atom. Like the first, it has 8 protons, it has 8 neutrons in the nucleus, it will have a couple levels for the electrons, and it's got 8 total electrons, so just like before, I'll put 2 electrons in level number 1, I'll put the remaining 6 electrons in level number 2. So the first level is stable, it's filled. The third level is unstable, it's not filled. It doesn't have 8 electrons, it only has 6. So what's going to happen when these 2 atoms are both unstable? Well, in this case, they're going to form a covalent bond. they're going to overlap their electron levels and share their electrons. So when you count up the electrons of oxygen number 1, 2, level number 1 is stable. How about level number 2? Level number 2 has 1, 2, 3, a shared fourth, a shared fifth, 6, 7, 8. Level number 2 was once unstable, but it is now stable because of the sharing of electrons. Let's look at oxygen number 2. Oxygen number 2 has 1, 2 electrons in the first level stable. Look at the outside level. 1, 2, 3, 4, a shared fifth, 6, 7, a shared eighth. Because they're sharing electrons, oxygen number 2's outside level is now stable. So if I set those electrons in motion, those shared electrons are zigzagging back and forth, kind of like in a figure 8 right here. And because of this sharing of electrons, both oxygens, oxygen number 1, oxygen number 2, they have filled outside levels. That's a covalent bond. Let's look at an ionic bond next. So the definition of an ionic bond, it's a bond where one atom gains an electron and another loses. Remember, atoms make bonds in order to become stable. They're trying to fill their levels of electrons. A classic example is sodium chloride. Na is sodium, Cl is chlorine. You put the two together, you have what's also called salt. Well, here's the square for sodium from the periodic table. The 11 is the amount of protons. That's the atomic number. I know sodium has 11 protons. So there they are. If you remember from earlier, the protons and the electrons are usually found in the same amount. So I now know sodium also has 11 electrons. The 23 on the bottom is the mass. The combined protons plus neutrons for sodium adds up to 23. So we just said 11 protons plus what mystery number equals 23. Simple math, sodium has 12 neutrons. All right, let's put this together now. So let's put this atom of sodium together. The protons and neutrons are clumped in the nucleus. I'm going to add 1, 2, 3 levels for the electrons. You'll see why I added 3 in a moment. Level number 1 can only carry 2 electrons. Hey, at least it's stable. It's filled. Level number 2 can hold 8 electrons, so I'll put 8 of them in level number 2. Level number 3 can carry 8, but there's only 1 left over. So when we look at the levels, level number 1 is stable, level number 2 is stable, but level 3 is unstable. Level 3 can carry 8 electrons, but there's only 1. That makes it unstable. All right, I want to put that note in the upper left-hand corner to remind me that sodium has 11 protons, 11 electrons. It also has 12 neutrons, but because neutrons have no charge, we don't need to focus on them. Well, I want to shift focus away from sodium to now I want to shift our focus to chlorine. From the periodic table, the 17 is the atomic number or the amount of protons. If you remember, the proton number is pretty much always going to be the same number of electrons, so I now know chlorine has 17 electrons. The mass is 35. That's 17 protons plus what number equals 35. That means chlorine has 18 neutrons. So now I want to draw the chlorine atom. It has 17 protons. It also has 18 neutrons in the nucleus. So now when I draw the electron levels, 1, 2, 3 levels for the electrons, I got to draw 17 electrons. I can only put 2 electrons in level number 1. It's filled, it's stable. That means there's 15 electrons I have to account for. I cannot put all 15 in level number 2, but I can put 8 in level number 2. That will leave me a total of 7 to account for. I can put all 7 in level number 3. I hope you see the problem though. Level number 3 is not filled. It's not stable. So look at level number 1 for chlorine. It's stable because it's filled with 2 electrons. Look at level number 2. It's stable because it's filled with 8 electrons. The problem lies with level number 3. It's unstable. It's not filled. There's only 7 electrons in level 3. 8 will make it stable. So just like last time with sodium, I want to put a reminder in the upper right-hand corner for chlorine. Chlorine has 17 protons, 17 electrons. I want to see that to remind me as we go through the next part. Look at my definition. An ionic bond is where one atom gains an electron, but another loses. Watch what chlorine does. 3, 2, 1. Chlorine is stealing an electron from sodium. That's going to completely change the amount of electrons that each has. Sodium used to have 11 electrons, but it just lost one. It only has 10. Chlorine used to have 17 electrons, but it just stole one. It just gained one. It now has 18. Well, let's look at the levels of electrons to see if they're stable. Sodium on the left, 2 in the first, it's stable. 8 in the second, it's stable. It doesn't even have a third level anymore. That's okay. Look at chlorine on the right. 2 electrons in the first level, it's stable. 8 electrons in level 2, it's stable. Chlorine used to have an unstable level 3, but it just took an electron from sodium. It now has the desired amount of 8 in level 3. It too is stable. But how do these things actually stick together? Watch this. Sodium on the left is actually like a positively charged magnet now. It has 11 protons. Protons have a positive charge, and only 10 electrons. Electrons have a negative charge. So because it has more protons, it's positively charged. Chlorine, it's just the opposite. Chlorine now has more negatively charged electrons. That gives it a negative charge. What happens when you put a positive and a negative magnet together? They stick. They bond with one another. The positive charge of sodium is attracted to the negative charge of chlorine, like two oppositely charged magnets. Magnetism draws them together, and that's what holds them together in an ionic bond. Sodium is a positive magnet, chlorine is a negative magnet. They bond together ionically. So there you have it, the basic differences and similarities between covalent bonds and ionic bonds. Go ahead and pause the video if you want to compare and contrast the two. I hope you found the video really helpful. Leave your thoughts below in the comment box. I look forward to reading them. Take care. Best wishes to you.